Question number 5 is to write the full electron configuration for chlorine and chlorine minus. So when we write down the electron configuration, it helps when we follow a set of different steps. So the first step is to divide your periodic table into the different orbitals S, P, D, and F. So let's look up what that will look like. So you kind of get something that looks like this. And you can see the first two columns is the S block in the light blue. And this green section is called the P block. And then the middle transition metals is the D block. And then finally, the bottom two rows, the lactanides and actinides, is the F block. So for step 2, starting at hydrogen, we move left to right across the periodic table until we get to our desired element. So in this case, it's chlorine. And then we would write the row number followed by the block letter. And then you write the number of electrons in that orbital shown in the superscript. And then one more thing I'd like to add is that when you get to the D block, you write the row number -1. And when you get to the F block, you write the row number -2. Okay, so after a lot of practice, it kind of gets pretty tedious when you write electron configurations. So first we're going to write the full electron configuration for chlorine. So again, let's find chlorine on this periodic table with all the different sections labeled out. So you can see chlorine is found here, atomic number 17. And then starting from hydrogen, we're going to move left to right across the periodic table, writing the row number, which is 1, followed by the block letter, which is S, and then the number of electrons that are in the 1s orbital. So in this case, s orbitals can hold 2 electrons, and this shows the electron configuration of helium now. And then let's go to the next row. We have 2s and then 2. And then when we get to the P block, the P orbital can house 6 electrons. So we will write 2p6. And this only brings us to the neon. So we have to move to the next row, 3s2. And then we get to the P3p orbital. And then just count out how many electrons until we get to the chlorine. So 1, 2, 3, 4, 5. So we write 3p5. So this is the electron configuration for a ground state chlorine atom. And if we wanted to write the shorthand configuration, we would find the noble gas that comes before chlorine. So in this case, it's neon. And then we'd write neon in square brackets. And then just continue on writing the electron configuration as is. So you write neon and then 3s2, 3p5. So the shorthand configuration is helpful when you need to write the electron configuration of an element, like closer to the bottom of the periodic table, like mercury and platinum. Like you don't want to just write all of the different numbers and letters. You can just write the noble gas that comes before it, and then just continue on with the rest of the electron configuration. So now we need to write the electron configuration of the chlorine ion. So chlorine minus. So chlorine minus has an extra electron, and we know that because it has a -1 charge. So since it has an extra electron, this is going to change our electron configuration. So we're going to add an additional electron. So the first part is the same, 1s2, 2s2, 2p6, 3s2, and then once we get to 3p, it's now going to be 3p6. And if we were to write the shorthand configuration, this would be the same electron configuration as argon. So now we just write argon in square brackets, and these are the two electron configurations. So the junior tutor said that a neutral chlorine atom has 17 electrons, and following the mnemonics, the configuration for chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. So Cl- must have one more electron than the neutral chlorine, so this makes it have 18. So this is isoelectronic with argon, but the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so isoelectronic means that they have the same electron configuration. So this solution is correct.